Hello student, very good morning to all of you. I hope you all are fine, happy and healthy at home. Did you remember what were we discussing yesterday? Yesterday I think we were discussing about the retrosynthetic analysis of some of the molecule and their synthesis. So far we have discussed I think 3 molecules. Now today we are going to consider the target molecule TM4. So that is the target molecular number 4 that we are going to discuss. So the target molecule number 4, this is the structure of target molecule 4. Because target molecule means what? The molecule whose synthesis being planned is called as target molecule, and they are represented by the frame numbers TM1, TM2, TM3 like this. And we are discussing about retrosynthetic analysis. What do you mean by the retrosynthetic analysis? According to the definition of retrosynthetic analysis, let me recall that definition again. The process of breaking down the target molecule into convenient starting material by using disconnection and functional group interconversion is called as retrosynthetic analysis. Means we are interpreting the molecule, and then this is the retrosynthesis. Retrosynthesis means what? Retrosynthesis and retrosynthetic analysis, these are the two different terms which are involved in a retrosynthetic analysis or a disconnection approach we are generally. And in a retrosynthetic analysis, if you listen this definition carefully, there are two important words are involved. One is a disconnection and another one is a functional group interconversion. And disconnection means what? Disconnection, it is one of the important step involved in the retrosynthetic analysis, which is very prominent, very significant, and according to its definition, the disconnection means it is an analytical operation which break a bond and convert a molecule into a possible starting material is known as disconnection. And another important term involved in the definition of retrosynthetic analysis is a FGI, or full form of FGI is a functional group interconversion. And the definition of that functional group interconversion is like this: the one functional group is converted into another functional group so that disconnection becomes possible. So that which we, and generally that FGI is written over the disconnection arrow, and we know that disconnection arrow, the meaning of that symbol is could be made from, and though there are some different type of the arrow, their symbol and what are their meaning, that also we have discussed. So today let us begin with the target molecule number 4. See this target molecule. Now what are the things while analyzing, while doing as a now I am doing the retrosynthetic analysis, which is a upper. Suppose this question, that type of the question for 4 mark. So first retrosynthetic analysis, the weightage of mark is 1.5. So what are the things you have to analyze? You have to write in the retrosynthetic analysis. You have to observe that target molecule carefully. And first point, recognize the functional group present in the target molecule. And as I already told you, what do you mean by the functional group? What does it means? Functional group is nothing but, as a shortest definition of the functional group, is a site of reaction. Or in other way around, we can define it in the general organic molecule. The part of the molecule undergoes a change. That type of the part also called as a functional group. Or in a general way, we can define the functional group in such a manner that the atom or group of atom that determine the physical properties as well as chemical property of a particular family of the organic compound is known as functional group. So that functional group, first at a glance, when you observe this target molecule, at first glance you should notice that what are the functional at a T.Y.B.Sc level. Only one functional group disconnection we are discussing, not the multiple group discussion. So focus your concentration on only the one functional group. And which one functional group is present here? There is a carbon-carbon double bond. It is a functional group present in that target molecule, or it is a final product, right? This final product has one carbon-carbon double bond, which is the functional group. The name of this final product, the name of this target molecule is a cyclohexene. Let me cyclo means a cycle is there. Cyclohexene mean indicate as a 6 carbon involved in the ring. So it is a cyclo, and the ENE indicate there is a carbon-carbon double bond. So this is the name of this target molecule. Once you have done this, then we have recognized there is only one functional group, which is a carbon-carbon double bond. This carbon-carbon double bond, how could you obtain this one? So first one, show this arrow. This is the disconnection arrow. On that, the usual way, the usual representation of this target molecule, we must mention on it, that is a FGI, right? FGI means what? Functional group interconversion. Functional group interconversion means what? Because this retrosynthetic is a powerful technique, powerful concept. It is channelizing your brain. You have to think, you will be on the way. The aim of this chapter, the aim of this point, to introduce you to the basic concept of retrosynthetic analysis. Once you have read and understood it, you will be on the way to designing your own organic synthesis. You are on the way. You are able to innovative thinking. But that thinking must be as a logical one. You should not go anywhere. Whenever you are going to do the functional group interconversion, one of the functional group is converted into another functional group. You must know how you can convert, because both are interconverting to each other. So that way you have to think, and after thinking that this double bond we can make, because that making process must have, before breaking that bond, before converting that functional group into another, from that we can prepare, we can get our this original functional group there. So that way you have to think while doing that doing that disconnection. Now I am putting one of the hydroxy group over here, right? And as we know that the name of this molecule is a alcohol, that is a cyclohexanol we got over here, right? cyclohexanol. And one cyclohexanol, once you got the alcohol, as I have already told you that you remember whatever alcohols you are getting in the that alcohol, whether it is a primary, secondary or tertiary, we can prepare that alcohol using the Grignard's reagent, and Grignard's reagent is a very good reagent. By using that Grignard's reagent, we can prepare different type of the alcohol, maybe primary alcohol, secondary alcohol or the tertiary alcohol, and that's why it is a versatile synthon. Variety of the organic compound we can prepare by using that reagent, and that's why that Grignard's reagent is very important as far as organic chemistry is concerned, and that is the Grignard's reagent, because these Grignard's reagent which is obtained from the alkyl halide and pure magnesium metal in presence of the dry ether, resulting complex form is RMgX, is known as Grignard's reagent. And the speciality of that, it can be react with the carbonyl group. As we know that carbonyl groups are present in aldehyde or in a ketone, so if that only primary alcohol is obtained with the formaldehyde and the epoxide, that ethylene epoxide, if you remember, or that type of the compound gives you produce the primary alcohol, and other aldehyde, acetaldehyde onward, whatever benzaldehyde, propanaldehyde, butanaldehyde, all gives the secondary alcohol. And when the Grignard's reagent treated with the ketone, all kind of the ketone, they are maybe as aliphatic ketone or the aromatic ketone, treating with the Grignard's reagent followed by hydrolysis, produce the compound which is a tertiary alcohol. That you have to remember. And once you know the alcohol, and as we know that how the alcohol get broken down, or how disconnection is appear over there. Let us see here this sigma bond forming as a double bond with this, and this bond is breaking like this. After the disconnection, what you are going to get? You are going to get here is a OH aldehyde group, and then rest of the thing over here. Here you got as a negative charge, and remember this negative charge means carbon atom carries as a negative charge. That species is called as a nucleophile, which we have learned in first chapter. But in this chapter, negative or positive, either negative or positive, whatever species after the disconnection obtained, they are associated with polarity, and that has a special name in the retrosynthetic analysis, which is a synthon. Synthon is nothing but as after the fragmentation, after the disconnection, whatever positive and negative species are obtained, that species are called as a synthon. That synthons are the species which are associated with polarity, is known as a synthon. Now we got the synthon over there, and as we know that synthons are highly unstable, and it is trying to stabilize it, and there is a synthetic equivalent always present over there. And now this synthon must have a synthetic equivalent, and that synthetic equivalent represented by such type of the three lines. So here negatively, so you should insert the metal near that carbon atom, so that is nothing but as a synthetic equivalent. Let me draw here again. This is a aldehyde group. Now this we are writing, and here is a magnesium bromide, which is called as a synthetic equivalent. So this is synthetic equivalent. Synthetic equivalent means what? A compound carries a reagent carries a function of synthon is called as synthetic reagent. Understood this one? What do you mean by the synthetic equivalent? Means what? Synthetic equivalent, a reagent carrying out the function of synthon is called as a synthetic equivalent. So that you should remember like this. So this is the retrosynthetic analysis of this molecule of the cyclohexene. We got this will be the starting material. We can break into as a smaller fragmentation. We can arrive at the smallest starting material, but as far as the T.Y.B.Sc level is concerned, T.Y.B.Sc is concerned, you have to break, disconnect up to that is enough to get as all the mark, whatever weightage are there, 1/2 mark, so you will get. So you have to show up to this, no need to show another one. So that is, so specifically I am resting here. So because here again we can show there, but no need to show that one. Now let us look at as a second part is a actual synthesis. Now you can do the synthesis over here, and synthesis means what? Synthesis starting from the starting from the reactant, starting from the starting material. Here we got the starting material is this one, and by using that material, starting material, we can obtain that compound, or this we can show this can be obtained from this one C double bond OH, and then this one, and you can draw as a Br like this. So up to that you can, or what, this Grignard's reagent can be obtained from this type of the alkyl halide containing as a carbonyl group. So let's begin the synthesis of this target molecule, which is a cyclohexene. Now I am starting from this, right? Now what I am taking over here, C double bond OH, I am writing as it is this one, now Br, and now I am adding magnesium metal, pure magnesium metal in presence of dry ether. Why the dry ether is employed here? Do you know the reason behind it? Yes, the dry ether is employed over here if there is a moisture contains. This reaction is a very vigorous reaction takes place. If the moisture containing over there is a accident takes place or explosion may occur, and to avoid such explosion or to avoid the accident, the dry ether, this solvent is always employed over there to avoid the such type of the such kind of solvent always use over there. Here what is that? Let me draw properly over here, so that you can see this one clearly. Here C double bond OH, then here we have insert this complex form, and this complex is known as a Grignard's reagent. Gr, remember here Gr means nothing but as a Grignard's reagent. In short, I am writing that one. And once you got it, Grignard's reagent, and after that Grignard's reagent, you treat this is a negative charge forming, because near the metal always carries the positive charge. You must remember this one. And now adjacent one is a negative charge, and this negative charge is generally attacking on that oxygen atom, and you are going to get this type of the intermediate. So here O, Mg and Br. So that is the intermediate you got over here. So this is the intermediate, and this intermediate further hydrolyzed with H2O in presence of H plus. This process is known as a hydrolysis. What is going to happen? This bond is a very labile bond. It get easily cleaved, resulting compound formed will be this one. I am representing that compound over here, so you can see clearly here is a O and H, right? So this is the what we can call it as a, we have got the alcohol which is there, cyclohexanol we got, and cyclohexanol, as we know that there is a, if you use as a dehydrating agent, as we know that the good dehydrating agent is a concentrated sulfuric acid. If you use over here H2SO4 which is a dehydrating agent, or we can use Al2O3 aluminum oxide which is also as a dehydrating agent, what they will do, they can remove the water molecule from the substrate or from the reactant, and the resulting product form will be the target molecule. Because here dehydration, 1H from here and OH from here, double bond is came here, so this target molecule you are going to get this one, and this is nothing but our cyclohexene. So in this way we can prepare this type of the organic compound in the laboratory or in the lab. So in this look at this one. Now the next molecule we are going to consider over here. So let's see the another target molecule over here. So let us consider the target molecule number here. Let me clean the board first so that we can see the clarity, or the once the clear board, so you can see the very easily the whatever reaction which I am going to write on the blackboard, you can see very cleanly over here. So let's begin with the target molecule number 5, right? Now this will be the consider the target molecule Tm is a 5, and this consider the target molecule Tm number 5. So let me draw over here the target molecule is this one. Let us see here this one, then CH2O, then C double bond O, and this is the compound, this is a this is our target molecule, right? CH2O, C double bond O, and on both the side benzene compounds are there. So this is a benzyl benzoate. The name of this target molecule is a benzyl benzoate, which is a this is our target molecule. Now I already told you that first thing is do the retrosynthetic analysis. Retrosynthetic analysis means what? As we know that the process of breaking down the target molecule into convenient starting material using disconnection and functional group interconversion is known as retrosynthetic analysis. And what is the first point to observe this target molecule? Carefully recognize, identify the functional group present in the target molecule. If you observe this molecule carefully, benzyl benzoate, what do you see? There is only, because we are at a T.Y.B.Sc level, we are talking about only, we are discussing about, or we are considering only the one group disconnection. So once you got it, first recognize the functional group in the target molecule. First identify the functional group in the target molecule. That is the first things to do. Immediately you should notice that how many functional groups are present. So at a T.Y.B.Sc level, let me tell it again, the functional group, only one functional group, one group disconnection we are using at a T.Y.B.Sc level. So remember, only one functional group is present over here. Look at, if you observe this structure carefully, you will see there is a one ester group is present, right? And there is a speciality of that group, how we can break, how we can disconnect. So first one, you draw this type of the arrow, this type of the arrow, this is a disconnection arrow, and as we know that disconnection means what? It is the analytical operation which break a bond and convert a molecule into a possible starting material is known as disconnection. Now I am going to break. There are the various possibilities are there, but I am not going to show you the various possibility. Only one possibility which is better, which is most preferable and suitable, that because at the beginning I already told you that your thinking power must be think in a logical way so that you can disconnect properly over here. Suppose I am breaking that bond between these two, carbon and the oxygen, which is easily breaking the bond because I have in my mind I can make that bond, and that's why I am breaking that bond. So that is the way of thinking while disconnecting that bond. When I am disconnecting this bond, then I must show over here this one, the fragmentation I am getting over here, this one, then C double bond O, and then this is a benzene part over there, right? This is the fragmentation. This is the species I am getting. Now by using the common sense, now tell me where should I place positive charge and where should I place a negative charge? Can you tell me? Yes, because as we know that one general rule is there, when the hetero atoms are present and the bonds are generally breaking heterolytically, and when the bond is broken heterolytically, always remember the more electronegative element must have a negative charge, because whatever electron shared for bonding, that more electronegative atom taking both the electron and forming as a negative charge. That the one general principle everyone must remember. So here, as we know that oxygen is a more electronegative in nature, so you should place negative charge on it. Remember this one, you should place as a negative charge, but most of the students placing as a plus charge, they don't do that. Remember, oxygen atom is a must be positive. Now once you are putting as a positive, other species you must put the positive charge over here. Positive charge must be here, right? After breaking, or don't show again negative charge. Some of the student may be showing as a negative charge here and negative. Don't do that. Once the heterolytically bond is broken, one should get as a negative charge, other should get the positive charge. Oxygen is a more electronegative in nature, and therefore always remember it should get the negative charge, and the carbonyl carbon, as we know that it is electropositive in nature, and so I am putting as a positive. This is the way. In this way you have to think while disconnecting that bond. After that we can make it. Now what is the next point to do? When after the disconnection, whatever fragmentation we got, they are the synthon. These are called as a synthon, right? These are the synthon. Now, and as we know that synthon are highly unstable, and now they must get associated with the synthetic equivalent. Every synthon must have a synthetic equivalent, and as we know that synthetic equivalent means what? The reagent carrying out the function of synthon is known as a synthetic equivalent. Got it? Now and they are represented by such type of the three lines that indicate as a synthetic equivalent. Now I must keep that oxygen negatively charged, so that I must bring there is a electropositive atom or the element. Now what I should brought over here, see here, because you are first time you are looking, I am joining, there is a hydrogen atom, I am attacking as a hydrogen atom, I am connecting as a hydrogen atom, so that the negative charge of that oxygen atom, it remains, is maintained as it is, and now here is a positive charge. What should I bring over there, so that I can keep the positive nature, electropositive nature of that carbon atom I should keep as it is, and now I am connecting here, which is a HO. That HO we know that is a negative, and it must be as a positive in nature, and therefore this is called as a synthetic equivalent. This is also known as a synthetic equivalent of this type of the synthon, and as we know that this is a benzyl alcohol, this is a benzoic acid, and this benzyl alcohol as well as benzoic acid are available in the market. By using this, you can use this as a starting material, and you can prepare your target molecule, this one. So further you can break that also in another type, as we know that this alcohol can be broken like this, so you can show the broken like this, and negative charge on this carbon atom, so that we will get this type of the thing over there, minus charge, and another one you will get as a formaldehyde, right? Formaldehyde are easily available in the market, and what should be the this is a synthon we got, right? This is a synthon, right? And this synthon must have a synthetic equivalent. The synthetic equivalent, for showing as a synthetic equivalent, you can represent three lines, so that you can get it from that, as we know that here is a MgBr, if this type of there, and which is nothing but as a Grignard's reagent, and this Grignard's reagent can be obtained from bromo like this. This is a Br, and the magnesium metal you can get it. So this you can call it as a this disconnection arrow and the FGI, functional group interconversion. So in this way we can do this, or that benzoic acid can be readily available, and if you go for MSc, after that you can prepare. This can be obtained from toluene can be obtained from what we can call it as a Friedel-Crafts alkylation reaction. So you can do that one also, but here you can, or let me show this one also. This can be obtained, you can do as a FGI, functional group interconversion, and this can be obtained from this one CH-3 toluene, and that toluene can be obtained from again from, if you break from there you will get CS3Br, and what we can call it as a, here is a benzene. After breaking this one you may get over here, let me show this again clearly over here, their fragmentation CS3, here positive charge, and here negative charge, here like this. So let us see over here, up till that toluene you can remember, or toluene can be obtained from this one CS3 Br and the benzene, as we know that. Both are the starting material. From that we can obtain. Now this is the retrosynthetic analysis. Now let us begin with the synthesis. How do you synthesize these molecules in the laboratory? Let's begin with the synthesis over there. Now is a synthesis, right? Synthesis. Now first one, take down, that is a bromobenzene over here, like this, Br, then pure magnesium metal in presence of dry ether. What do you get? This type of the compound you get over here. I am representing this one, this MgBr, which is a Grignard's reagent, and that Grignard's reagent further treated with HC double bond O formaldehyde. I am going to get over here, this negative is going to attack over there. I am going to get here, the compound is like this, C, then O minus, H, H, and here you can write MgBr like this, and then you can do the hydrolysis, H2O in presence of the H plus. What do you get? You are going to get over here the compound, this one. After the hydrolysis you will get the compound, this one. This is a CH2 and OH, that is a benzyl alcohol. You can call it as a A over here, right? And this A, now another, this is, you can call it as a suppose this way. Another one, we know that the starting compound is a benzene, and that will be treated with CS3Cl in presence of AlCl3. As we know that this is the one of the famous reaction. What is the name of that famous reaction? Everybody know that. More than 95 of you might be knowing as this reaction, one of the famous reaction. Anyone can tell me what is the name reaction? This is called as a Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation reaction. This is, and in this way we can get this one, right? The CS3. The methyl group is introduced over there, and now this will be treated with alkaline KMnO4, right? KMnO4, you might be knowing that alkaline. This should be as a alkaline in nature. What you will get? You are going to get as a benzoic acid over there, C double bond O, and this is a OH, right? And this you can call it as a B over here. Once you got A and B, just here you A plus B, and under what we can call it as a H plus catalytic amount of the acid, and you will get as a target molecule here. This is your target molecule number 5. Means what? A, you know that, right? A is this one. I am writing here CH2OH. And B, as we know that benzoic acid HO, then C double bond O, this is a benzoic acid, as you know that. Then OH is going to attack over their carbonyl group, and there is elimination of water molecule, and the resulting compound formed will be this one. So this is the compound you are going to get, CH2O and C double bond O, and this is a benzoic acid, right? This is your target molecule we got over here. So in this way we have seen the retrosynthesis and the synthesis of this target molecule. I think with this let us stop today here. Remaining molecule we will see in the next lecture. Thank you. Have a nice day.